In this chapter, we will understand deep learning. Well, not so deep. We shall focus on deep learning concepts, its working, and its application that can possibly bring transformation in pharmacovigilance. Are we aligned? Okay, let's understand how a human brain works. The human brain is the most complex organ and is responsible for major functions of the body and decision making. It's made up of billions of brain cells called neurons. Neurons communicate through electrical and chemical signals. The electrical signals propagate to thousands of other neurons, which further leads to formation of thoughts. To make a machine learn and think like human, a corresponding neural network has to be built within the machine, and this neural network is called as artificial neural network. Artificial because it's not real. Well, that's obvious. It's named as deep learning because it adds layers to the network to learn from the data. In a way, it's going deep and deeper for learning just like the human brain does. If we look at the definition, deep learning is a specialized form of machine learning that learns from the data and functions, similar to human nervous system, where a complex network of interconnected computational units work in a well-coordinated way to process complex information. Deep learning can be applied to image analysis, speech recognition, language processing, to name a few. In the context of pharmacovigilance, case intake process can be the biggest beneficiary from deep learning. In case intake, there are elements of language translation, image recognition, and decision making to identify adverse events from large pool of data. Deep learning is a type of machine learning, and this will follow the regular pipeline for building the model. This means the training data can be pre-processed, used for training the model, test it, validate, and deploy to production. Of course, this goes through the improvement cycle. It is true that it learns from data. However, the data is not labeled. It learns by discovering data patterns or the trends. The computational units in the network are called as neurons that receive, process, and deliver the output. On the left, you see here is an input layer that receives the input data. The rightmost is the output layer to finally produce the output expected. And in between, the hidden layers or the processing layers are present. The neurons work based on how they perceive the received input and pass the information to the neurons in the next layer. Looking at the way the neural networks work, there are three types of such networks present. First one, feed forward network. This is the simplest and passes on signal only in the forward direction. It does not have a memory to store previous data, and it does not loop back or provide feedback. Next one is CNN, that is convolutional neural network. This is mostly applicable for image processing. The CNNs automatically select the features and classifies the images. There is no need to feed the features to CNN. It's able to find hidden and relevant layers for the learning purpose. It applies the convolution operations on the input data and send the output to the next layer. Does it sound too complicated? Well, let's try to keep it as simple as possible to understand. Okay, now the next one is RNN, that is recurrent neural network. This network came into picture to address the sequential data problems with feed-forward model. Feed-forward model was not able to store the previous data, and every time it would consider the input data as new data. This means if the output was dependent on the previous data, it's not going to be the right network to choose. For example, the data involved in weather prediction is considered as a sequential data. The weather prediction for next 2 days may rely on past week's data as well. Feed forward network is not going to help here because it would not store the past data within the network. Having understood deep learning to some extent, you might be thinking, what is actual need of deep learning? See, we have machines that learn from data and the humans that have the real brains. Then why do we need to have deep learning? Three very simple reasons. Number one, data explosion. Take example of any business, any industry. Data is exploding everywhere. The same is applicable for drug safety as well. We know there are multiple data sources for adverse events, be it company's database or health authorities database. Data from social media, electronic health records, and other portals are increasing. Deep learning comes to rescue as neither human beings nor machine learnings can handle this massive amount of data. Next reason is solving complex business problems. Solutions to complex business problems may be dependent on many factors. In case of an adverse event and a drug's association with it, there can be many factors like the concomitant drugs, the diversity of the patient groups, the dosage, food habit, and there are so many other factors as well. Do you think human brain can consider so many factors and solve the problem? No, neither can a machine learning. Deep learning can learn the patterns and the features independently, and that's a strength of deep learning without manual feed. This is not possible with machine learning, where you have to feed the data to a great extent. So, what do you think? Can deep learning disrupt the pharmacovigilance industry and transform it? Absolutely, there are possibilities. It's going to change the future of drug safety. The risk benefit related answers that we do not have today can be answered tomorrow. Thank you. I hope it was a good session for you to learn on the concept of deep learning and possible applications in pharmacovigilance.